Can I invite our final challenger in this series? It's called Team iProof, and they will be joining us via video conference.
Good afternoon, gentlemen. Can you hear me?
They're in the UK. Give us a second. We'll get the video conference tech running. There you go.
Good afternoon, gentlemen. Can you hear me?
Yes.
Excellent. Thank you very much for inviting me, and I'm sorry not to be there in person. My name is Andrew Budd. I'm the founder and CEO of iProof. We provide a service that authenticates remote users online in a way that is incredibly simple, but also incredibly secure. And we do this using technology which we have developed entirely ourselves. Let's go to the next slide, please. Just a few words about us. We've been going about 3.5 years. In the last decade, I was the founder, the CEO, and the executive chairman of a company called Mblocks. Go back one slide, please. I was the CEO of a company called Mblocks, which is the world's largest provider of enterprise-to-consumer SMS. A couple of members of my team, my CTO and my commercial director, are a business which last year turned over about 6 billion transactions. But to source the world-class machine learning technology, I've been able to access the skills of the computer science department at University College London, which is one of the world's top faculties. We have a number of granted patents on our technology, and our service is currently live and in production. It's been recognized by a number of awards. We were grateful to receive the KPMG Global Award for Fintech and Cybersecurity. We are very much favored by the financial regulator in the UK, the FCA, who have introduced us and welcomed us into a number of their events. And as of the beginning of this week, we are in the latest cohort of the Microsoft Accelerator. Next slide, please. The challenge we set ourselves was to provide a good way to establish trust in a remote user. And by good, we mean usable by all members of society, whatever their age, ability, or device type, but also secure against large-scale, sophisticated cyber attacks of the sort that are only too clearly feasible and will become increasingly a danger to us all. And as I think everybody knows, current methods, exampled here, are neither usable nor secure. So the industry needs to do better. Next slide, please. The method we adopted was face verification. There are a number of reasons why we did so. The main one is usability, that you look at your telephone, it looks back at you, it could not be simpler. But also, the sensors are ubiquitous. Every phone, tablet, and laptop has a front-facing camera. And also, the credential is available, securely stored, and also printed on many identity documents. So face verification is very good, and today actually face matching technology, as we'll talk about in a few minutes, can work extremely well. But there is one huge problem that lies at the center of this particular technology. Next slide, please. So people get very excited about the face matching technology and perhaps their face is being stolen. Nobody needs to steal my face. You can just get it on LinkedIn. Faces are public credentials. And therefore, the fundamental threat, the core of security for face recognition, is the ability to detect spoofs, replays, and also lies. There is only I only have one real face, but there are many possible copies. And so the central question in any face verification system is, can you detect a copy? Can you detect a replay? And these copies can range from simple things like high photographs to the sort of sophisticated attack which is illustrated here, was published in an academic paper last August, where a fully moving, blinking, smiling, textured virtual reality copy of a person's head was generated from 4 or 5 Facebook images that they had posed publicly. This method, which looks very much like a real human being, broke systematically every single face verification system that it was presented to. That's the kind of threat that we have to take seriously. And finally, there's the whole issue of compromised devices, which is obviously very much in the news today, which don't even bother to spoof the face or to go into too much analysis. It just tells lies. So how have we solved this? Let's have a look at the video of our solution in action. Next slide, the video, please. You'll notice the user has had to click twice and to look at their phone and not do anything else at all, and thus they've authenticated. It could not be simpler. So how did it work? Well, the key lies in the flashing colors. Proprietary technology, it's patented and it's quite unique and it works extraordinarily well. So just as the person starts to authenticate, they click on the screen. Please click for the animation. And we generate in our servers a code which is sent there and then to the device. That code tells the screen how to flash, and during the flashing, a video of the person is sent back to our servers. In our servers, we do the face matching, and I'll talk about that in a second. We look at the way that the light from the screen reflects off and interacts with their face. That immediately helps us to solve the very hard problem of whether we're looking at a photograph or a video on a screen or some other forgery. But we also look at the sequence of colors, which is unique every single time the person authenticates. And if the sequence of colors, the order of them, that reflects off the person's face is correct, then we know they're in front of the camera now, live, the way that I'm live talking to you. But if that sequence of colors is wrong, then what we're actually looking at is a recording, which has been stolen from the device or the network sometime in the past. So the combination of the face match, the 3D revelation from the way the light reflects, and the flashing tells us unambiguously that we're looking at a real live human being. Now, the face matching itself is a deep learning system that we developed ourselves. We started by licensing in some of the best technology in the world, and we developed mainly for the passport industry, and we found that it wasn't very good for this sort of application. So we were the first company in the world to develop a commercially available deep learning-based face matching system, and it works extremely well under a wide variety of lighting and pose conditions. Now, up until now, the application of this can either be to authenticate a person against an image of themselves that they enrolled in the branch or under some other sort of secure environment, or it can also be used to authenticate them against their own document. Next slide, please. So here we see an image of the person drawn from their document, and that image can either be stored and retrieved electronically if the document is an NFC-based biometric document, or it can be captured visually using the camera of the smartphone. What we then do is we take those images, which are supplied to us by companies who specialize in documents, and we, who specialize in faces, then capture the selfie. We check that it's a live selfie and not a replica, and we compare that selfie against the passport image that we've captured. And our performance in doing that is about 10% better than the best available online services today. Once that's been completed, and it's done entirely automatically with no human interaction, we can confirm that the person presenting the identity document is the same as the person depicted in that identity document. When they come back later, we can confirm that they are the same user returning. Let's just see a quick video of the NFC-based version in action. Next video.
Now, another exciting application of iProof is for remote onboarding. Here, we're confirming that it is a real, unspoofed user presenting an identity document. We've worked with our partner, Dutch document experts Innovaler, to build a revolutionary new solution. To tell you more about this application, here is Ronnie Kahn, Innovation Lead for Norwegian bank DNB.
Thank you very much, Andrew.
Now let's quickly run through and watch this amazing new approach. So, first, Ronnie scans the passport to pick up the machine-readable characters that are printed along the bottom of the passport. That gives him the key that then enables him to read the information stored in the biometric passport on the chip by means of NFC. So that's information which is securely stored on a passport, is now being securely passed to the handset, and from there securely to the servers. Amongst that information is a high-resolution image of Ronnie. In the final phase, Ronnie 8 years ago. In the final phase, Ronnie now authenticates himself to the image that was stored on the passport using iProof. So I'm afraid. So as you can see from the flashing light on his face, he just iProofed. And once that's verified, this will now confirm that the owner of the document is really physically present. There he is. Ladies and gentlemen, that was one of the very first secure remote KYCs.
Andrew, you have about 30 seconds to wrap up.
That's fine. So this is my last slide to conclude. Applications of iProof for what you've just seen. Initial identity capture, authenticate a returning user using any of their devices, and based upon your understanding of their authenticity, the ability to issue a one-time passcode which you can use as a signature on a document. Thank you very much indeed.
Okay, we'll start with a few questions. I have a note for the jury. In between your questioning, the Chief Minister may suddenly come online for his live video conference. I will interrupt your questioning and come back to the questioning later. Andrew, we have the Chief Minister who's scheduled to join us sometime during the next 10-15 minutes. If that happens, unfortunately, I'm going to have to interrupt you and come back to you for questions later. For now, let's start with the questions from the jury.
Andrew, this face recognition technology developed by your company, has it been patented?
So you can't patent deep learning face recognition technology because the basic principle was the subject of an open academic paper published by Facebook and the University of Tel Aviv in the summer of 2014. So the principle of deep learning-based face verification is open. The real skill and the technology that we've developed is to apply it in a way that works well in the specific circumstance of someone comparing an image taken at 30 centimeters from their face, 10, 20 degrees below eye level. Know-how that is embodied within the structure of our deep learning classifiers. You can't patent that, it's a trade secret.
And you have a quick question in terms of the performance of your solution. Can you give me a few benchmarks in terms of what was the size of the database vis-a-vis the total number of records, the images that were stored inside, against which the authentication was made?
So the training set is counted in millions of images. The speed of the system is extremely scalable. So we can authenticate against about 100,000 users in under a second, and it scales in the nature of deep learning, but it scales extremely fast. In terms of the speed of the system that you saw in the video is actually not really determined by the speed of the face matcher at all. There are other processes that take longer. In terms of the performance, when comparing the false accept rate when comparing selfies either to each other or to passport photos is about the false accept rate is about 1 in 10,000. We want to compare that with the performance of human beings when matching, there is an academic paper that shows that human beings comparing trained passport officers comparing selfies against photographs have a false accept rate of 15%. I'll repeat that because it's such an astonishing number. It is 15%. So machines are enormously better than people, even than, in many cases, than super recognizers at comparing people. Our false reject rate is currently running at about 3%.
Andrew, what's the specification for the front camera that you need minimum?
I'm very sorry, the internet just broke up there, so I'm afraid I didn't catch that at all. Would you mind repeating?
Do you have a particular specification for the front camera where you take the photograph?
Low-end laptops, so we will work with an ordinary VGA camera. We are thrilled by the superior quality of the cameras that we find on most mobile phones.
Just an offbeat question. Given that in India, for unique identification, we use iris apart from fingerprint. What are your views in terms of how facial recognition you would consider as superior than iris?
So the problem that we're trying to solve here is completely different. In iris, what you're trying to do, iris is very, very good if you're trying to identify an individual out of a billion other individuals. And faces are completely useless for doing that, because actually the chance of you looking almost exactly like another person is about 1 in 10,000. So if you're trying to identify someone, irises are really good and faces are really bad. But if you're trying to authenticate somebody, to compare them with an image of themselves, then frankly the difference between faces and irises is inconsequential. Whether there's an accuracy of 1 in 10,000, 1 in 50,000 is irrelevant. What matters when you're trying to authenticate people is your ability to recognize a spoof, because that is the way that you attack these systems. The security of these systems is all about spoof recognition. And there is much more richness and information in a face than there is in an iris. So it's much, much easier to spoof an iris than it is to spoof a face when you are using unprotected hardware and standard hardware like a mobile phone in an uncontrolled condition. So for that reason, I would say that if you are authenticating, face verification is much, much better than iris recognition, than iris verification.
Andrew, hi. Tell us a little bit about your customer traction numbers and what are the real life problems that you faced while implementing some of these customers?
So traction is just beginning now. You can, if you want to try out iProof freely, you can download an application from the Apple App Store called FaceScript, which is a personal data store which makes use of it, and we have users doing it all over the world. We are currently contracted with the UK Tax Authority, Her Majesty's Revenue and Customs, to run a very large-scale trial, which hasn't started yet, but has been subject to user testing. So some of the problems we don't have is in usability. So HMRC tested our system under laboratory conditions with a lot of users, and they found that 100% of users could authenticate successfully with iProof first time with no instructions. We do have we have challenges with people not understand. We do occasionally have challenges with people not understanding what they mustn't do while iProving. So we have people turning away during the flashing or starting to talk, typically. And we have people, and we do have occasional problems with odd Android handsets that have bizarre features about them, but we work through those. Carefully. We do occasionally have problems with people who try to iProof deep within the firewalls of very locked down financial institutions, because the deep packet inspection interrupts the flow of video between our device, between the handset and our servers, but we seem largely to have cracked that, although it can sometimes make the experience a little bit slow.
Is your product hosted on cloud?
So that's a very interesting question. At the moment, so the answer is we run it as near bare metal in cloud as we possibly can. And so, for example, we are just in the process of moving our servers from AWS to Microsoft Azure, because we are involved in the Microsoft Accelerator program. We can run our services on any bare metal that obeys our specification, and indeed quite a number of the financial institutions to whom we're moving towards deployment are asking us to run our servers on metal inside their data centers on premises, and we can absolutely do that.
Another question is more about the nuances specific to our geography in India, where network connectivity is still leading a lot of road to be paved way for. Given where you are in UK, you might have your solution hosted in one of the cloud service providers and being accessed over a high capacity network link. Do you see any challenge in terms of an environment like our geography, where the network links are not that rich, so to speak? So what is the minimum bandwidth that you have tested your solution against?
So you must never underestimate how bad the UK mobile networks actually are. I believe that Indian network engineering is better than British mobile network engineering, quite frankly. We will run quite happily over a 3G link. The total data load is about